All right, good day, students. We have a question to solve, and the question is on solid shape. We have a cone of height 9 centimeter, and it has a volume of n centimeter cube and a curved surface area of n centimeter square. Find the vertical angle of the cone. So the first thing we need to understand here is that the magnitude that we're given and also what we are actually asked to find will now bring together the relationship, what connects them together. First, we need to identify the volume of a cone, which is given as n, and we also need to identify the curved surface area of cone, which is also given as n. And how do we write the volume of cone? So this is the volume of cone, and also the curved surface area is also as pi r L, where L is the slanting side, R is the radius, and H here is the height. So, and according to the question, we're given that n centimeter cube is the volume, n centimeter square is the curved surface. So we can conclude that n is equal to n, so the curved surface area is equal to the volume of the cone. So this is what it means. So we have equated the volume of the cone together with the curved surface area. So and to minimize this, if we divide both sides by the pi, so we will not have pi here, we will not have pi here. And also we divide both sides by r. R at this side is r squared, r at this side is just 1r. So it will reduce it to be rh over 3 is equal to L. And do not forget that we're given that H is equal to 9 centimeter. So we can substitute that here to have 9R over 3 is equal to L. So let us take note of this, and we'll divide this 3 here and 3 here. So we have 3R is equal to L. So this we have here, we can express it in terms of ratio, which tells us that 3 over 1 is equal to L over R. L over R. So as it is like this, we can conclude that 3 ratio 1 is to having L ratio R. So this is it in terms of ratio, how it looks like in terms of ratio. Now let me bring out the cone shape. So this is a cone, and as according to this cone, we have it that the height is 9 centimeter and the radius is r. Don't forget, the slanting side is also L. This is the radius r, and this is 9 centimeter. So we don't jump to conclude that 3 is for the slanting side, 1 is for the radius. No, we only have them in their ratio. So we have them as it is in their ratio, but we have validated that 9 centimeter is the height of the cone. Now, I'm bringing out a right angle triangle that is in this cone, the one that has to do with the height, the radius, and the slanting side. So if I am to bring out that shape, I will have it like this. Okay, so this stands to be L as the hypotenuse side, and this stands to be the adjacent part, which is the radius. Don't forget, what we have here is 9 centimeter. And we need to know what is our radius, and possibly we may further find what is our slanting side. And do not forget, we're given the ratio, we really still need to know what is that ratio as it is of its height. So now let's have a right angle that has to do with the ratio part. This is 1, this is 3. And to know this side, we can use Pythagoras theorem. And to have that part now, the Pythagoras theorem, it tells us hypotenuse squared is equal to opposite squared plus adjacent squared. So having the hypotenuse as 3 squared is equal to opposite is unknown. That is what we're finding. Plus adjacent squared, which is 1 squared. So this is 9 when this 1 times 1 comes to the other side becomes negative minus 1 is equal to opposite squared. So this is 8 is equal to opposite squared. So it tells us that the square root of 8 is the opposite. So having the square root of 8 as the opposite, which can be reduced to 2 root 2. So what we have here in terms of ratio is 2 root 2. So we can now make use of this to compare the other triangle we are having at this side, which tells us that we can use it to find the radius, we can use it to find its length inside. But precisely what we needed is the radius, because the question actually asks us to find the vertical angle of the cone. So to have the radius now, we can use the ratio 9 over r is equal to this side as well, 2 root 2 over 1. So, and when we have this, we can simplify it. Then crossing multiply, having it, then r will be equal to 9 root 2 over 4. All right, and to have this in a basic term, let's put it up here. Okay, the vertical angle of the cone, that's what we're asked to find. So let me quickly take this as 9 over r is equal to 2 root 2 over 1. So when we cross multiply, we have this becomes 9 is equal to 2 root 2 r. So dividing both sides by 2 root 2, we're going to have r is equal to 9 over 2 root 2. And when we rationalize this, we multiply by the square root of 2 and of 2. So r is now 9 root 2 over 4. So as according to how we have it down there. So now we have the value of r, and we have to find the vertical angle of the cone. And to get the vertical angle of the cone, so what we use is that we use tan theta over 2 is equal to r over h. So we now know what our r is in centimeter, and we have our h as it is given initially. So this can be tan theta over 2 is equal to r as 9 root 2 over 4 divided by 9, which is the height. So, and this can easily be simplified to be 9 root 2 over 4 times 1 over 9. So if this 9 take care of this 9, so what we have left is root 2 over 4. So root 2 over 4, let's add that one here. So that tells us that tan theta over 2 is equal to root 2 over 4. So we take the arctan of both sides, then we have arctan of root 2 over 4. So computing this on our calculator, what the arctan of root 2 over 4 is 19.47. So, and when we have it this way, we can now cross multiply to know the exact value for the angle theta. So that makes us to have 2 times 19.47, and that is 38.94 degree. So this is the vertical angle as it is required. Thank you for watching.